Welcome to today's lecture on merge sort. Let's talk about what merge sort is. It is a sorting algorithm that follows divide and conquer approach. How does merge sort work? We repeatedly divide the array into two halves and then repeatedly merge the divided elements back together in sorted order. We will use recursion to divide and then to merge the divided halves back together. Now how we can sort ARR using merge sort in ascending order. What we have to do is divide the array continuously using recursion until we just have one element in each array. Let me show you how we can do that. Divide this array into two halves and then divide those halves further into two more halves and then further until we just have one element in each array. This is how we divided array into equal halves again and again until we just have one element in each array. Now what we will do is, after we have all the elements in separate arrays, we will merge them and we'll first sort them and then merge them. We'll merge these two arrays in sorted order. We'll merge these two arrays in sorted order. We'll merge these two arrays in sorted order. We'll merge these two arrays in sorted order, and we will keep doing it until we have the original array in sorted order using merge sort. And therefore we just sorted this array using merge sort in ascending order. Let's talk about merge sort algorithm using Python now. We will have two functions, merge sort and helper function merge. We will talk about merge later. Let's focus on merge sort right now. What merge sort does is it divides the array recursively into two halves until we just have one element in each array. This is the base call of the recursion, which returns the array once we have just one element in array. This divides the array into equal halves, left half, right half, and then it recursively calls the merge function every time we divide the array into equal halves. Let's talk about merge function now. The work of merge function is to merge back the divided arrays in sorted order. We have two positional arguments, left, right, and we have a result array where we will store the merged elements. And we have I comma j to represent the indices of left array and left half and right half respectively. We have this example here. Let's suppose we have a left array of 5 comma 3 and right array 1 comma 6, and we will store the result merge result in this result array. And we have this while loop, and the condition to terminate this while loop is when we reach the end of either left array or the right array. And we have these if else conditions which state that we will compare the element in left with the element in right, and whichever element is smaller we will append that to the resulting array. And since we appended from right, we'll move j rightwards. And now we will again compare this left element with right element. Since 5 is smaller, we'll append that to result. And then since we appended from left, we will move it rightwards. Now again we will compare the element from left with the element from right. Since 3 is smaller, we'll append it. And since we have reached the end of the left array, we will terminate this while loop. And now we will, using these two lines, we will append any leftover element. Since 6 was not added to the result array, it will be added using this line, and then we will have a result array 1536, and we are returning that result array here. Let's run our code in VS Code now. We have this merge sort function here and a helper function merge that we just talked about. Let's suppose we have an array 3, 11, 9, 1, 0, 6, and we want to sort this array using merge sort in ascending order. Let's run our code. And here we go, we have the array in sorted order 0, 1, 3, 6, 9, 11. The time complexity of merge sort is big O of n log n, and auxiliary space is big O of n. And additional space is required for the temporary array used during merging. Thank you for watching this video. I hope to see you in the next one.